Today is day second of this week. And today we'll be talking about a few more things, right? So let's do a quick recap about things that we did yesterday, right? Let me share my screen. And yesterday we talked about this folder structure. We talked about scripting component. We created our own script, right? And with the help of script, we saw that how can we actually manipulate our scene? How can we change our, change some properties, get some values, set them, right, and get them. Also, we checked about the properties, right, the components that are present here, and also we got to know that not all properties of every component are visible on in the editor. We also talked about the how can we learn about multiple more properties about any component. That is by going to the Unity documentation. One was scripting API, second was Unity manual, right? So that is all that we did yesterday. Okay. And today we will be taking a deep dive into how we actually get, user input. Like till now we were doing everything, that was static. That means we just coded it and we had no interaction with it, and the code just executed. Now we will be seeing how can we add some interaction, how can we take some inputs from the user, and how that works. Okay, so let's get started with it, and we can use this very same scene. And let's see, so here we go. Let's continue in the learn script only. We can continue in that as well, otherwise we can make a new script. Okay, so I guess let's make a new script. Okay, so we'll say create C# script and user input, maybe script. Okay, so in this script, what we'll be doing is we'll be getting some user inputs and we'll see how that works. Okay, so let's start simple, let's start small, and let's see how things work. Okay, so till now we were doing a debug log, right? We were doing some debug logs, right? Now let's do a debug log when user does something. Okay, so to get the input from the user, for example, if you want to get user input from keyboard, this is how we do that. There's a class known as input, and in that we can do get button down. Okay, so you can go through these and this will actually give you a basic overview of this. So get button returns true while the virtual button identified by the button name is held down. So this will be given true whenever a button is being held down. Okay, for example, this is a button, this is being held down, this is button up, button down. Like if you're pressing it, this is button down. If we leave it, this is button up. Okay, so this function will be called whenever the button is held down. Okay, let's go to this one, get button down. This will return during only one frame, only once. Whenever the first time the button goes down, this will be triggered. Then this one will be triggered when the button comes up. Okay, so this is for buttons, this is for keyboard buttons, right? What if we want to take a look on the mouse buttons? Okay, so for that we have get mouse button down, get mouse button up, get mouse button. Okay, so let's get started with this get mouse button down, and we will also be seeing differences between these functions. Okay, so here we are saying now which button, so we can get the button name by keycode dot any button, maybe B. Okay, so now let's unwrap this in an if statement. So we are saying if the user presses button B, okay, and we are getting an error here. So inside this, we can simply see we'll get a string. Okay, so key code dot why are we getting an error here? Keycode returns an event keycode, the map directly. Okay, so this says this is not a string. Okay, let's see. So this is the time you learn. Okay, you see how can we learn. So as of now, we're stuck on this thing, and now we want to know like how does this work? What is the error? It says that we need to give a string here. Okay, so let's jump onto Unity's documentation. Okay, so this process, in this process you will be learning what if you're stuck somewhere, what if you want to learn like how does things work. Okay, so let's write input dot get button down Unity. Okay, and this shall actually bring us to the scripting API, and here we can see what we are missing. Okay, so here it says basically we want to get the button name. Okay, so this says that this is file 1. Okay, so basically we want to have a string here. Okay, so what else can we do? Okay, this is get input access, get access, which is the access which we'll be talking about lately. Okay, so now let's see if we have input dot get key down, right? So this is the one we should be using. Okay, so basically for get button down, we need to actually enter the button name. Okay, whatever button's name it is, it should be string value. But for get key down, we can simply give this a key. Okay, and this should be good to go, right? So input dot get key down, and here we can pass the key. So we want, for example, whenever we press C, okay, we want to do something. So let's do a debug.log here, and let's say C button C key pressed. Right now, let's go to a Unity scene and let's see what happens. Okay. So basically now it should be okay. Again, we have the script here, right? This is not in the scene. This is just in the project view. So let's get this screen, in the scene. Let's get the script in the scene. So let's put it on the controller itself. Okay. So here we have the learn script. Let's disable it. Okay. So now this won't be working anymore. Okay. Let's click on play and let's see what happens. Okay. So on console, we have nothing. Okay. So now I'll be pressing A. Nothing happens. I'll be pressing S, D, F. Nothing happens. But as soon as I press C, we get a log, C key pressed. Okay. So this is actually we are taking, we are taking some action based on the user input, right? Okay. So now let's go to, now let's see if, how to get the maybe mouse button. No, let's see, how get key up works. Okay. So we did get key down. So let's say key code.c. Okay. So on button down, this will be logged, and on, when we release it basically, so we say released. Okay. So let's see when each of these work. When are these triggered? These functions are triggered. Okay. Let's click on play. And so again, I'll be pressing C and I'll keep pressing it, and then I'll leave C button. Okay, let's see what happens. So pressing C. So we have C key pressed. Till now, I'm still pressing key, and as soon as I release it, C key released. So on the get button up, C key is released. Okay, so we have this debug. So this function is called whenever we are just pressing the first time the key is pressed, and this is called whenever the first time the key is released. Okay. We saw another function, right? And that was get key. So this is called as long as this is pressed. Okay. C key is being pressed. Now let's see what happens. Okay. So what actually should happen? This is a good practice before running your program to just check your knowledge. What you should do is you should visualize what would happen. So see the code. So here we have get key down. So this should be called as soon as the button is first time down. Okay. This should be called whenever this is first time released. And this should be called for the time whenever this is being pressed. So every time when it is already pressed, every frame, this should be called. Okay. So what should be sequence of the debug? First, this should be printed. Then we keep pressing it. This should be printed multiple times. And then as soon as we leave it, this should be printed. Okay. Let's see that in action. So see, okay. So as we saw, as soon as we pressed it, C key was pressed. This is event is called. This debug is called, and this C key is being pressed. It's being called again and again and again and again. And as soon as we leave the C key release is called. Okay. So this is how you know these functions work. So now you have a good understanding. People, or initially students get confused with these two. Okay, get key and get key down. So get key down is just for initially as soon as the button is pressed, this is called once, and get key will be called every time till the time this button is being pressed. Okay, and as soon as we leave the button, it is in its normal state, then this is called once, C key released. Okay, similarly, let's see, there's an action for mouse buttons. Okay, so here we'll say input dot get mouse button down, and here we have to basically put an integer. So 0 stands for left click, 1 stands for right click, and 2 stands for if you have a mouse on that, if you click the scroll button, right? And all this information, if you want to get, what you can do is you can control a command, click on this, and here it gives you a basic in overview. But the better view is go to your browser and simply write get mouse button down. Okay, and this shall straight away take you to the scripting API. So here, when you read about things, the description and the examples, things become pretty clear. Okay, returns true during the frame the user pressed the given mouse button. All this in up from updates, functions, and state gets, it will be true. Okay, so here it says button values are 0 from the for the primary button, often the left button, 1 is for the secondary button, and 2 is for the middle button. Okay, so let's see this in action as well. So we'll be pressing, I'm on a mouse pad here, so I can show you demo of 1 and 2, right? Sorry, 0 and 1. That is left click and right click. I don't have a scroll button to click, right? So here, let's say, let's debug left button click. And similarly, if a right click, which on a mouse pad is, maybe a double click, not a double click, but a 2-finger click. Okay, this is good. Let's again see things in action. Let's hit the play button and let's see what happens. Okay, here we are. First of all, for the C thingy, okay, I just clicked here, right? So left button clicked. I just clicked here with 1 finger. Left button clicked. Left button clicked. And sometimes this may happen that this option is clicked on, that is collapse. This means if you have a same log, it won't print it again and again. Instead, it will just increase its number. So this is 3 times printed. If I click again, because the log is same, the value will increase. Okay. But if you want to see separate logs, you can do like this. Okay. So let's clear them, and now I'll be clicking by 2 fingers. Okay. And we have right button clicked. Right. Again. Yeah. Okay. And also our C button functions are also there. So if you press C, we have C key is being pressed. That was for the one. C pressed, C pressed. Okay. So that is how it works. So now we have learned how can we take some input from the user. Okay. But this is, as of now, we are just using the key, any key on the keyboard, or maybe the mouse. Okay. Now let me give you an idea about a few more things. Okay. And let's go to project settings, I believe. And here it should be something known as input manager quality. No, I think it's in preferences. And here also I can't see it. If we define our access as editor, graphics, now input manager. Oh yeah, here we have it in the input manager itself. So we have access. Okay, so there are multiple accesses that we can get the input. So here basically multiple buttons have been defined. Okay, let's see horizontal access. So here we can define. Okay, we can define things like here we have horizontal access where we have named it horizontal. So we can reference it by the name of horizontal. Its negative value will be from the left button, like left arrow. Positive value will be from right arrow. Also, alternative buttons will be A and B. Okay, left and right. Okay. Another one is vertical one. Here we'll be using the up and down arrows or S and W arrows. Okay. So these are accesses. Here we have also defined some buttons, right? Left control should be this button and whatnot. So this is the way we define things. Okay, we have defined our accesses. Now let's get, and here we can also define the type. This is a key or a button. Which axis does it correspond to? It corresponds to the x-axis. Okay. So let's use these. How do we get the, how do we get the value of this? So we say, again, if you have no idea about, how to get access, simply go to Unity right here, input dot get access Unity, and you should be shown up again scripting API. And here it tells us the same things in input manager. You can tell the access name, you can set the positive and negative buttons, right? And here it gives us an example as well. Okay. So if you want to get the access, we simply say get access mouse X, get access mouse Y, get access horizontal, vertical, right? If you change the name, okay, perform a mouse look. So yeah, so let's get this, the value of this. Okay, let's see what it prints. Maybe so input dot get access. Which access do we want the value here? Horizontal. 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 Okay. Okay. So this will give us a value, right? This will give us a float value. So basically, this gives us value from maybe from 0 to 1 or -1 to 1. That should be it. Okay. Okay. So let's create a float horizontal and let's say input dot get access. Let's say to get the horizontal access. Similarly, let's ask it to get the vertical axis. Axis. Okay. And what we can do is we can actually create these variables here. Float horizontal axis value. And should vertical axis value. Why we are doing so? So that we can see these things without debugging them, and we can actually see the value of these in the inspector itself. Okay, and let's say horizontal axis value here. And axis value. Let's save this. So whatever value that we have on these axes will be stored into these variables, and these are public variables, so we would be able to see them. Okay, we should be able to see them in the editor itself. Let's see in action. So yeah, things have saved. Let's click play, and on controller there are these two, horizontal and vertical. Okay, so let me press the left mouse, sorry, the left arrow button. Okay, so as you can see on the horizontal axis value, it goes from 0 to -1. Okay, and if I press the right mouse button, it slowly goes from -1 to -0.5 to 0 to 0.8 and then to 1. Similarly, the same should happen if you press A and D, A or D. A on the left, that's -1, D on the right, that is +1, because these are the alternate buttons that was set up in the axis, right? We go to, again, go to project settings, we can see in horizontal, left and right, and alternative buttons are A and D. Okay, so A, again, -1, 1, D should be 1. Similarly, for the vertical axis, it should be W should go to top, that is 1, and S should go to -1. Up arrow should go to 1, as you can see here, and it should go to -1 if I press the down arrow. Again, left arrow, horizontal axis, -1. Right arrow, +1. Up arrow, vertical axis, +1. Down arrow, vertical axis, -1. So this is the value of axes. Okay. So now till now we've understood how we can get some input from the user, but we haven't used this input to do something substantial. Okay. So what shall we do? Let's get hold of our pretty cube, right? Okay. And let's try to move the cube. Okay, and let's see different ways of moving a cube. So moving a cube means changing its position. Okay, so let's write if input dot get key down is code, say p. Okay, what do we want? We want the cube. We don't have the cube. We don't know the cube, right? So let's create a variable so that we can actually set the cube. What is this game object? Right? As we already know, every object in Unity is a game object, right? So this cube is also a game object, and we can actually set the cube here because it's public. So this shall be visible in the editor. Here we can drag and drop the cube and set it. So let's now try to change the position of cube on user input. So we will be saying that whenever we press T, okay, whenever we press T, get position of the cube. Okay, so here we are aware that we want to change the position. That is a part of the transform component. Okay, so let's create a transform type variable as well. Cube transform, and in starting, what we'll say is cube transform is equal to cube dot get component type transform, and save it in cube transform. So now we can simply access cube transform dot position is equal to whatever we want here. So on T, what we want is we want to maybe add one in y-axis. Okay. So what we can say here is we can simply either write cube transform dot position plus vector 3 dot up. Okay, what is this vector 3 dot up? This will be 0 1 0. That means up direction, that is x-axis way 1 point up, 0 0 1 x and z. On y it will be 1 point up. So either we can write like this, cube position means, for example, cube is here. Okay, we are saying whenever we press t, a cube position is here. What you have to do is set the cube position to wherever it is, plus 1 in y-axis. So 1 in y-axis. So if cube position is 0, so plus 1 in y-axis will be 1. Okay, so it will be 0 1 0. If cube's position is 1 2 3, okay, and we add only 1 in the y-axis, so what will be? It will be 1 3 3. So wherever the cube will be, its position plus 1. So cube will be set one step higher. Okay, so let's try to play that and see what happens. So this should only happen as and when we press T. That is the main thing that we need to consider. First of all, we need the references, otherwise we'll get an error. So let's play. Okay, so I'm playing here. We'll get an error. Why? So first of all, we see an error here. We see an error here. What is this error? This error says unassigned reference exception. The variable cube of user script has not been assigned. This says this variable is not assigned. And where from this error is coming? From where this error is coming, we can see here. This is coming from this user input scripts. You click on this line and it should take you to the exact line. So 14, we are saying cube transform is equal to cube.get component, but we haven't set anything in the cube, right? So it is saying you have a missing reference. You're trying to find a component in nothing. You want something there, right? That is why the error. Let's stop this. Let's add this here. Okay. Also, let's remove this parenting stuff. Okay. And the position of cube, let's say 0 0 0. Okay. And here we have referenced it. And let's hit on play. And again, nothing happens. Cube position as of now is 0 0 0. Let's see what happens if I press A. Nothing happens. As soon as I press T, this should, rise one unit above from wherever it is. And we can see the position change here also. We will see the position change here as well. Let's press T. This rose 1 unit. If you are not able to see this here in the game window, here you can absolutely see the position is 0 1 0, right? So now it's 0 1 0. Again, let's press T. Let's see what happens. Again goes up. Again. If you press, just keeps on going. Okay. So if you come in the scene view and see, okay, in the scene view, if you come and you try to press T, nothing will happen. Why? Because all the input that is to be taken is in the game view. Okay. So if you want to see game view as well as scene view side by side, you have to put them like this, and then click on this game view so that you're active in this game view. And now press T, and as you can see the scene window as well, you will be seeing the cube rise, right? Absolutely. And why are you not able to see this cube in the game view? That is because the camera, it has gone out of the view of the camera, right? That is the reason. That is the reason you're not able to see it. Okay. So if we move the camera back, now you can see the cube again. Let's press T, it shall go up. Okay. So that was a simple example of manipulating something by a user input. Let's make this more interesting. Okay. Let's again put a game window here. Let's make this more interesting, and let's do something fun. Okay. Let's create a plane. Reset it. Okay. Let's say cube should be on plane. Okay. So this should be 0.5 because cube's height is 1 and actually its center is in the between, right? So that is why if we set it to 0 0 0, This is half plane side. If we increase its height by just the half of its height, it shall be just on the cube. Okay. Now simply let's quickly add some materials. So using the full structure, create material using all the knowledge that we have. Maybe this is plain material and control D to make a copy of it. Name it cube material. Okay. Now for the cube, let's put the cube material on cube. Let's put the plain material on plain. Nothing changes because both the materials are white. So as soon as we change the color of things, they should change. Okay. Plain cube plain didn't change. Why? Maybe plane's material is not assigned. So it's plain. Okay, this dot was exactly in the left one, right? So we want it here. Okay. So now we have a cube that is on a plane. Right? So now what we'll try to do is we'll try to move this cube on this plane via user input. That's gonna be fun. So first of all, let's increase the scale of this plane. Now we have a pretty big plane, right? And let's set the camera maybe here. So if you want to set the camera to whatever you are looking at right now, you simply go to the camera, click on it, and press Control Shift F. And your camera view should be set wherever you are, right? On Mac, it should be Command Shift F. Okay. So now we want this cube. Okay, we want this cube to be moved by us by the input that we give it. Okay. So let's say if we say, so first of all, we have a controller user input, and we're already able to move it via pressing T and stuff, right? But what if we want to move it via arrows? Okay, so we can see we are already getting what we're getting here is the values, horizontal and vertical values, right? So let's say cube transform the position. So we are setting the position to what will be setting it to? Cubes, one way is cube's position plus a new vector. Okay, so that should be cube transform the position plus new vector 3, and here we want the x-axis to be controlled by the horizontal value. Okay, and we don't want it to move in the y-axis, right? It should not float in the air, and the z-axis should be for the vertical value. Okay, let's see what do we have now. Let's see what happens. This is all an update. Okay, so what this shall do is this shall, like, if we press forward button, the backward button, this should change the position. Okay, so let's see. So here, if you go, let me position myself somewhere here. Yeah. So now let's click on play. And as of now, I'm pressing the forward button. Oh, the cube did move forward, but it was too fast, right? So let's again get the game view side by side so we can give input by game view and see what's happening in the scene view. So this is really fast. As soon as I press up, this starts to move, and this happens really fast. Why is that so? Because this goes to, the value goes to 1, right? 1 unit. So it is moving the cube 1 unit whenever update is being called. Update is called every frame, every time. So frame, you can say, you can set the settings and it has 30 frames per second. Okay, so every frame this is being called. But if we don't want this, okay, we want this to be moving per second, right? No matter how many frames. So this should only move like 1 unit per second. What we can do is we can simply multiply this by time dot delta time. Okay, now what is this? Why are we doing this? because what is time to delta time? Okay, let's understand that. So time to delta time is the difference between the execution of this frame and the next frame, like this frame and its previous frame. For example, this was executed at 1 second and this frame was executed at 1.2 seconds. So the difference between them is 0.2 seconds. Okay. So this will multiply whatever value that we're having by time to delta time. This will make sure that we only move the part, like a part of it. Like in one frame, we don't move 1 unit, right? We just move 1 into 0.2. Okay. So that doesn't make sense. Let's go and understand time dot delta time unit. Okay. So this is the interval in seconds from the last frame to the current one. When this is called from inside this fixed update, it returns fixed time. Okay, that's not good fixed time. Time to delta time inside this is not reliable. The following example. Okay. So basically, we don't want things to be called on every frame. It shouldn't go like 1 unit. That is what we are saying. Whatever time it takes from going from one frame to another, you know, get the time. Okay, how much time that it has taken, and then multiply it by the value. So basically, let me give you an example. For example, if our first frame happens on 1 second and our second frame happens on 1.2 seconds. Okay. So earlier, without this time delta time, every frame we're moving 1 unit. Okay. In this frame also we're moving 1 unit. This frame also will be moving 1 unit. But after applying this time to delta time, we will be moving 1 into 0.2, which is equal to 0.2 units. Okay. Right. So multiple frames happen. So in a second, maybe if this is happening 0. Like every frame is happening 0. In 0.2 seconds, right? So maybe there are 4 frames in a second. So it will actually sum up to one moving it 1 unit in a second, right? So this helps us to move things in not per frame but as per second. Okay. So now it should be much smoother, much slower maybe. Okay. And yeah. So let's add. Now let's see what happens. First of all, let's zoom in here on the scene. And now let's click on, see, see how much it moved, just a little. Pressing forward button, now leaving forward button. Okay. So if I see the cube, its front is this. Okay. So if I'm pressing W, I'm moving in the front. If I'm pressing S, I'm moving backward. If I'm pressing A, I'm moving left. If I'm pressing left button, I'm moving left. If I'm pressing right button, I'm moving right. If I'm pressing D, I'm moving right. So with help of this, I can actually move right. So now we see here that the speed is pretty low, right? What we can do is we can simply add a public float speed variable, and we can multiply the speed as well. So this shall increase or decrease the speed depending on the value what I have. So if I have value more than 1, this will increase the speed. If I have value less than 1, this will decrease the speed, right? And we have made it public so that we don't have to come again and again to the script to change it. We can simply change it from the editor itself. Okay. So let's see. As of now, we have 0 speed. What will happen? It won't move no matter whatever input we are giving, because the speed is 0. So everything multiplied by 0 is 0. So it's not adding any position to the position of the cube. Let's add a 1. So it will move as it should be. Now let's add 5. So it will be moving faster. See? Now you want to add it, move it more fast. 20 maybe. Oh, that's a pretty fast cube, right? So this way we have created a simple cube to move. This is one of the ways of moving this. Okay, we are adding the position. Okay, so another thing that we can do is we can actually use cube transform dot translate. Okay, and we can say how much we want to translate, and that should be this basically. So this again, what it does is this simply translate. So let's see. So translate is move the transform by x in x-axis, y in y-axis, z in z-axis. We don't like we already have a function, in transform component to move things. Okay, we don't have to do this like position plus, the added value. We can simply use this. So let me comment this, and now let's see. So translate. Okay, this is another way of moving the cube. Although under the hood, it's doing the same thing, right? So here again, the speed is 0, let's say 5. Now we are able to move, say 50. Let's go super fast. Woohoo! Yeah, it's a bit difficult to control. And as you can see now, you're adding functionality for the the user to enter input. Now you can see how you can create games out of it, right? How you can create more functionality out of it, right? That is how things work. Okay, so again, this is a translate function. Want to know more about it? How can we know more about it? We know how to know more about it. So simply write translate unity, and it shall take you to the documentation scripting API. Here you learn about it. So basically this is moves the transform in the direction and distance of the translation. If relative to is left out or set to self state, the movement is applied relative to this transform's local axis. If relative to is space world, the movement is applied relative to the world coordinate. Okay, that's something new. So we, as of now, we just use this one, right? Translate and some vector something. But here it says we have something known as space as well, which is known as relative to. This could be self, space dot self, or this could be anything else as well. Okay, so what is space? Let's get to know about space. M world space. Okay, it seems like space dot world is something and space dot self is something. So when we say self, okay, we mean like us, wherever we are looking. For example, we say this is a forward. Okay, we are looking forward. So for us, okay, let me give you an example in the real life for what is self and world space. Okay, if you're standing, watching the camera here, this is my left. Okay, right? Like my left would be according to me, like where am I facing? Left and right, left and right. Okay, so you are seeing me mirrored, right? That is why it's when I say left, it's your right. But actually, when you're facing, this is your left and right. So this is self face. If I face this way, now this is my left and this is my right. Okay, right? But for but how about north south? How about these directions? If I face this way, this is north now? If I face this way, this is north now? If I face this way, this is north now? No, that doesn't happen. So that is something you can relate to world space. So like which is fixed, right? And left right is something self, which is local to you. Like if you change your position, your left right changes, but the north south doesn't change. It stays wherever it is, right? That is difference, and that we can see here itself. So as of now, we see Q, and we see here if we this is the forward, right? As of now, this is showing this is the forward. Let me rotate the cube. Okay, and yeah, so here it says it's on the local position, right? Local forward. Now let's learn global. As of now, global forward is this as well. Okay, what happens if I rotate this on y-axis? Okay, my local forward has changed, as you can see here. Locally, I'm pointing in that direction. If I rotated myself like this cube 40 degrees, 45 degrees, I am facing that way now. Okay, right? This is Z is my forward. But this is my local forward. What if I say globally? Globally, still my forward remains same, right? Globally, I'm still, you know, this direction is my forward, this direction. So if I change it to 0, now local and global is same. Like this is my forward, right? But if I change myself, like if I rotate this cube 45 degrees, my local forward changes, but my global forward still remains the same. It is in this direction. Okay. So in transform, it was saying the same thing, right? It was saying you can specify space as well, where you want to move relative to what. Do you want to move in a local position forward, or do you want to move globally forward? Okay, so let's see that in action. So as of now, we are rotated 45 degrees. Okay, and this is globally, this is forward, but locally that direction is forward. And let's see what happens. If we play now, where do we move? Do we move globally or do we move locally? Okay, so as of now, first of all, we need to add some velocity, like speed. So as of now, we are moving as per a local system, right? Or what if we want to say, no matter how much anything is rotated, we just wanted to move, in the global forward direction, what we can do? So the script, it says what we can do is we can add another argument here that is related to, and we can say space dot hold. Okay, and if you don't give anything here, it will automatically take space dot set. Okay, that is why it was moving into the local axis. Now, first of all, let's set the value of speed is 5. Yeah. Now, let's see what happens. Let's go locally on cube, and we can see that our cube is like local forward is in this way because we are 45 degree rotated. Let me press forward arrow. It doesn't move in that direction. Okay. Let me press left arrow. It is not moving with the x-axis. With x-axis is pointing somewhere else, right? But if I see the globally, now if I press forward, yes, it is moving forward itself. So basically, it is moving globally now. Its translation is happening on a global scale, on a global level. Okay, not locally. So this is also something which you can take care of. And this is the benefit of reading the documentation. You get to learn things. This is how you learn things, right? So yeah, I believe this was all for today, and I hope you learned a thing or two, right? So here we did something really fun. We actually took user input, and by scripting, we were able to move a cube as a user wants. Isn't that amazing? Like now you know how these games work, mobile game or any computer game, how things work. And this is the best part of being a game developer. As soon as you learn new things, you get to relate it to actual games that you have been playing till now. And you learn, oh, okay, things work like this. This is so easy.